In problem number 4, we're trying to figure out a graph that is going to be similar to this. So as we try to interpret this graph, we can see that this line and this line downwards, both are going to have an acceleration equal to 0, as there's no change in velocity. This direction and this one. Now as we see this part of the graph, the middle part, we see that the direction is going to keep going upwards, until it reaches a point where acceleration is 0. In the meanwhile, the acceleration is going to, not the acceleration, but the velocity is going to change until it reaches this point. So to explain this a little better, we're going to get this part right here where the acceleration is 0, and we're going to give it some values. We're going to choose a graph going from 0 seconds to 7 seconds. So this part right here is the velocity, and this is just the time. So the velocity, we have 10 meters per second, and it's going to have a constant acceleration. It's not going to change at all. So using the formula to explain why it's 0, the change in velocity is going to be 10, the final velocity, and the initial velocity 10, which is the same value. And the change in time, as we said, is going to be from 0 to 7. It's going to be 7 minus 0. So 7 minus 10 is 0, divided by 7 should be 0. Now in terms with the velocity that's changing in the middle part, we can represent it as the following. We have the graph where the velocity from 5 to 6 will change in 4 to 5 seconds. So as we use the equation, acceleration being equal to change in velocity divided by the change in time, we should get 6 minus 5 divided by 5 minus 4. In this case, we don't have acceleration being 0, we have acceleration being 1 meters per second squared. Now if we use different values, let's say we get 8 minus 7 divided by, let's see, 4 minus 3. That should give us 1 divided by 1 equal 1. So as we keep going up, we're still going to have the same acceleration, so it's going to be constant. So as we see this graph, this is going to be pretty much similar to the given graph that we have in this problem. In this case, the line goes right here, starts right here, goes up, then keeps going, then it goes downwards, and finally keeps going this way. So as we see, in the beginning part, there's no acceleration and no change in velocity. Same thing in the final part, no acceleration and no change in velocity either. As we get to the top, in the middle part, we see a constant acceleration, which is a characteristic that we saw in this part right here for the previous graph. So constant acceleration, and at the beginning and at the end, the acceleration is equal to 0. So both of these graphs are equal to one another in regards to their characteristics.